All right, we're now professionals at using L'Hopital's rules on indeterminate forms of type 0 over 0 and infinity over infinity. That was what we learned in section 2.2. Now we're off to section 2.3. We'll look at indeterminate form of type 0 times infinity. Evaluating limits of type 0 infinity using algebra and L'Hopital's rule, that's going to be our goal. L'Hopital's rule only applied to limits of types 0 over 0 and infinity over infinity. To solve limits of type 0 times infinity, we will start by bringing one of the two factors as a denominator. So we'll start with a bit of algebra, and then we'll be able to use L'Hopital on the result. All right, so let's try one. If I just plug in infinity, I'm going to get infinity times e to the minus infinity because of that minus in front. Let me graph e. I really recommend that you learn the graph of e and the graph of log. That's going to give you most of the limits that seem impossible and strange. All right, so we're going to minus infinity here, and so the graph is actually going to 0. All right, so that's infinity times 0. This is one of the indeterminate types that we've talked about in section 2.1, so we don't know at this point what this limit does. According to the little sentence here, we should bring one of the two factors at the denominator to transform this limit into a fraction, either 0 over 0 or infinity over infinity. All right, so I'll talk a bit more about which terms to bring down a bit later, but if you look at this, the minus here means that it's really should be in the denominator. So I'm going to bring the e to the minus x. It's going to turn into e to the x. All right, and now the top is infinity. The bottom is infinity because at this point, I'm going this way. And so the curve is shooting up. And it's one of the two types on which I can apply L'Hopital's, and so I can apply L'Hopital here. I'm going to take the derivative of the top. That's going to give me 1. I'm going to take the derivative of the bottom. That's going to give me e to the x. And so when I plug it in, I get 1 over infinity. Remember, e to the infinity is infinity. And so I get 0. All right, let's try one more. Let's try x times ln of x as x goes to 0 plus. Just to kind of force you to draw it a few more times. I think afterwards you'll remember, hopefully. Here is ln of x. I'm going to 0 plus. That means I'm going 0, but from the right on the positive side. And so the graph is shooting down to minus infinity. All right, so that means 0, 0, and then ln of 0 plus. That's 0 times minus infinity. It does qualify as 0 times infinity. All right, I need to bring one of the two terms down. I could bring x down. That's fine. It's not great. Ln of x, if I bring it down, is horrible. And so because of that, because I know it's going to make my limit horrible if I bring ln of x down, and even worse if I differentiate 1 over log of x, how horrible would that be? And so I am guessing that bringing x down and turning into 1 over x, that's going to be the right call. All right, let's plug it in to see what we get. At this point, it should always give you either 0 over 0 or infinity over infinity, regardless of whether you pick the right one or the wrong one to bring down. So I get log of 0 plus, that's minus infinity. 1 over 0 plus, that's plus infinity. I do get an infinity over an infinity. So I'm allowed to apply L'Hopital. I'll get the limit as x goes to 0 plus. The derivative is 1 over x. A derivative of 1 over x, which is what I have in the denominator, looks complicated until you remember that this is really x to the minus 1. And if it's just x to the minus 1, it's a power rule, is x to the minus 2. All right, I think that what's tough here is it makes the derivative easier if you write it that way, but the limit itself, knowing it's plus infinity, is easier when you write it that way. So don't be afraid of going back and forth and using the one that's more comfortable in a setting. All right, let's bring this to the top to see if what cancels. I get x squared over x, and so I have minus x. When I plug in 0, I get 0. All right, let's recap this method before we start talking about which one's the right one, which one's the wrong one. All right, so the method for limits of type 0 times infinity, step 1, bring one of the two factors to the denominator. So either if you have fx times g of x, you could do f of x. Sorry, I need to put it higher. You could do f of x, and then if you bring g to the bottom, it becomes 1 over g. Or you could leave g of x on top and have 1 over f of x underneath. All right, so you turn it into a fraction a bit artificially. And then you apply L'Hopital's rule to the new quotient. Whatever you do, this is going to turn into 0 over 0, or it's going to turn into infinity over infinity. So as long as you haven't made an algebra mistake, you should be able to apply L'Hopital's rule. If it doesn't work, then either it wasn't 0 times infinity to start with, or you did this badly.